ఉంటుంది. అలా ఉజ్వల భవిష్యత్తు ఉన్న సబ్జెక్టుల్లో కెమిస్ట్రీ ఒకటి. అయితే రసాయన శాస్త్రం గురించి 10th క్లాస్కు ముందు నుంచే నేర్చుకుంటున్నా ఇంటర్లో ఈ సబ్జెక్టు మరింత విస్తృతమవుతుంది. అందుకే సీనియర్ ఇంటర్ స్టూడెంట్స్ కెమిస్ట్రీపై ప్రత్యేక శ్రద్ధ చూపాల్సి ఉంటుంది. వీరిని దృష్టిలో పెట్టుకునే KAB టెలివిజన్ క్లాసులపై ప్రత్యేక శ్రద్ధ పెట్టింది. అనుభవజ్ఞులతో క్లాస్ నిర్వహిస్తుంది. మరి ఈనాటి కెమిస్ట్రీ క్లాసులోకి ఎంటర్ అయిపోదామా? ఈనాటి కెమిస్ట్రీ క్లాస్లో కెమికల్ రోల్ టాపిక్ గురించి తెలుసుకుందాం. మరి ఈ టాపిక్ గురించి కెమిస్ట్రీ బోధనలో విశేష అనుభవం ఉన్న త్రివిక్రమ్ గారు వివరిస్తారు. మరి ఆ వివరాలేంటో తెలుసుకుందామా?
Today, let us concentrate on this. How do we understand the chemical role played by the substance? Because if you know the chemical role, then only we have point to decide the equivalent weight of the substance. These are a substance role as an acid, a substance role as base, as an oxidizing agent, as a reducing agent, sometimes even as a precipitating agent. So, if you look at a chemical reaction, a known chemical reaction, first we must understand what is the chemical role played by the substance. Then we can decide. And this acidity, basicity, etc. chemical roles can be understood when we look at the products of the substance. Suppose hydrochloric acid is an acid. So, it will react with a base, say like sodium hydroxide. Then the product is sodium chloride, water, okay, the other product. So, in this reaction, we understand HCl acted as an acid. To tell that, we usually mean like this. An acid shows its acidic character by utilizing its H plus ions. Say here, H plus ion from HCl, OH minus ion from sodium hydroxide, producing water. That is a key reaction in which hydrogen ions are utilized by HCl. So, it acted as an acid, we say. But an acid can have more than such hydrogens also. Suppose phosphoric acid. It has 3 hydrogens. It can get all 3 replaced. That means it can act as an acid by utilizing 1, 2, all 3 hydrogens also. But in one occasion it may use 1, in other occasion it may use 2. Depending on that, we are deciding that so-called N factor to decide the equivalent weight. But for that, in one reaction, suppose with sodium hydroxide, it gave a salt like sodium hydrogen phosphate, correctly disodium monohydrogen phosphate, giving water. So, in this reaction, phosphoric acid utilized 2 out of 3 hydrogen atoms, or we say 3 hydrogens were there, but 2 hydrogens got displaced here. Because 2 hydrogens got displaced while acting as an acid, it acted as a dibasic acid, so we take N factor 1. Similarly, for a base, OH minus, how many hydroxyl ions it utilizes? For example, each sodium hydroxide using 1 OH minus to act as a base, so we call that as monoacidic base. But in other occasion, we may find a reaction like this. Say, H3PO4, when reacting with calcium hydroxide, giving calcium monohydrogen phosphate and water. Here, calcium hydroxide behaved as a diacidic base. We mean out of 2 hydrogens or hydroxyl ion, it utilizes both of the hydroxyl ions for showing its basic character. So, in all acid-base reactions, we say number of hydrogen ions got displaced by that acid during the progress of the reaction with a base is this N factor. Similarly, for hydroxyl ion, for sodium, for bases like sodium hydroxide, calcium hydroxide, etc., the hydroxyl ion count will tell the N factor. These are the simpler examples where you find acid getting its hydrogen ions displaced, 1 or 2 or 3, depending on that decide N factor. But Similarly, hydroxyl ions replacement from bases. But we find some other reactions which are also acid-base reactions in which the substance may not have any hydrogen to get displaced, but still it can act as an acid. See, for this type of reaction, we can see examples like carbon dioxide, an acid, ammonia gas, a base, like this. In this, suppose carbon dioxide, when you pass through lime water, CaOH twice, this is lime water. In this lime water, when carbon dioxide is passed, it gives a white precipitate of calcium carbonate and water is formed. So, while forming this calcium carbonate, what is the role of carbon dioxide? We should say it is acting as an acid, because calcium hydroxide, a base, and carbon dioxide is an acid, and reacting with that, forming that calcium carbonate. But here, carbon dioxide is not having any hydrogens. To say, like in this case of HCl, in HCl we found one hydrogen to get displaced. In phosphoric acid, we see 3 hydrogens getting displaced. One time 1, in other time maybe 2, but there are hydrogens to get displaced. To tell it is acting as an acid because 2 hydrogen displaced, and therefore it is number 2 is N factor, etc. But here we are not finding any hydrogen atom to get displaced, but still we are saying it is an acid. Then how do you understand that it is acting as an acid? In this way, we can say for an acid to show acidic character, not that it will have hydrogen ions. When it is interacting with hydroxyl, carbon dioxide with hydroxyl ions, this is the reaction when you write shortly in form of ions like this to get this carbonate ion and water. So, carbon dioxide's role as acid differently appearing here, not to get hydrogen ions displaced, but hydroxyl ions with which it is interacting. So, we must say carbon dioxide interacting with the 2 hydroxyl ions here. Therefore, it is acting as a dibasic acid equivalent to 2 bases. Same carbon dioxide may react with one only OH minus, then it gives bicarbonate ion. So, while giving bicarbonate ion also, carbon dioxide is acting as an acid. But how? Monobasic acid with one OH minus, here with the 2 OH minus. So, to decide N factor, that means to decide the equivalent weight of a substance for an acid, we can say N factor like this, it is the number of hydrogen ions got displaced or number of hydroxyl ions with which it interacted. Similarly, for a base, just in reverse, for a base we can say number of hydroxyl ions got displaced from it or number of hydrogen ions with which it interacted. So, in that way, depending on the role played, we must understand this is acting as an acid, this is acting as a base, and then decide this is N factor, and so equivalent weight. So, I can give now therefore a formula to decide N factor in case of acid base reactions. So, this N factor, that is to convert molecular weight into equivalent weight, is equal to, for acids, N factor for acids is equal to number of H plus ions displaced from it or number of hydroxyls with which it reacted. Both ways you can say number of hydrogen ions got displaced from it or number of hydroxyls with which it reacted. So, situationally we must mean what is N factor. As we took in that example, say for phosphoric acid when reacting with potassium hydroxide, or anyways just for change I gave potassium hydroxide giving K3PO4 and water. Same H3PO4 in other reaction, say with calcium hydroxide, it is giving calcium, hydrogen, phosphate and 2H2O. And same H3PO4 when react